The next chapter is spectrum analysis. In this, we identify the sources of RF interference, right? So before we do the pre-deployment survey, we need to take a walk with the spectrum analyzer, and spectrum analyzer is the device that does the spectrum analysis and identify the sources of interference in the network, right? It's extremely important that we do that. So spectrum analyzers are basically frequency domain measurement devices that can measure the amplitude and the frequency space of any electromagnetic signal. So it can tell you what is the amplitude, what is the frequency space of any electromagnetic signal. So what these EM signals will do is they'll raise the noise floor of your transmission. Higher the noise floor, which means lower the SNR, and beyond a certain value, if the noise floor is high, the SNR becomes really low and your transmissions will fail. Okay, so if my transmitter is sending something and my receiver is not able to decode that because of high noise, the transmission gets corrupted. I'm not going to be able to send an ACK back, and the transmitter will think, okay, the signal was never received by the receiver, and then I need to resend. So it will cause retransmissions. Okay, so that's why we want to make sure that the source of interference is identified and figured out in that particular band. So this has to be possible, that the spectrum analyzer supports both 2.4 gigahertz and 5 gigahertz to scan. We want this to be the least minimum quality of my spectrum analyzer, that it should be able to scan 2.4 and 5 both. Okay, and when I say 5, I mean all the unibands. When I say 2.4, I mean the 2.4 band of 2.401 frequency to I would say this is where we transmit Wi-Fi signals, but the entire 2.4 gigahertz band is what we want the analyzer to be able to check. Okay, the entire band, not just this particular space. Cool. So we all understand what would be the problem if the noise floor increases and the SNR goes down. So we want to make sure this is taken care of properly. There are many sources of 2.4 gigahertz interference, which could be something like, let's say, a cordless phone, right? In 2.4 gigahertz spectrum, this can cause massive interference. The other thing could be a microwave oven. Usually they are shielded, but over a period of time, the shielding can really go bad. So usually they're shielded. The microwaves do not come out, but over a period of time they can start to come out. The other thing would be the 2.4 gigahertz video cameras. Okay, we can see something like a Bluetooth device. Okay, this is also a cause of problem. We can see something like a plasma cutter. So examples like this. Now all these things or all these devices can actually cause major interference in 2.4. And not to forget the last one, the nearby 802.11, 802.11b, 802.11g, 802.11n, WLANs. Let's say I am working in a multi-tenant building, right? This can be a major issue because I have different vendors on the floor above me, on the floor below me. They can also have SSIDs created. So the SSIDs on their floor can raise the noise floor on my floor as well, right? So for example, if my radio is trying to transmit, or there is some sort of an interference in my area, or let's say it's working on a particular frequency, And if there is an interference source in my frequency which is transmitting at high altitude or high amplitude, which what it's going to do is, the moment my client tries to send traffic, it's going to do CCA on layer 1, that is physical carrier sense. It's going to sense the RF energy already in the frequency, and it will defer the transmission. It will not send anything, which means because of the high noise floor, my radio did not even transmit anything. Okay, so that's another problem. So with nearby .11.11b g and WLANs, my AP or can think that okay, there is another AP on the same frequency transmitting data, so I need to wait, I need to stop. So we need to fix this, we need to figure it out. And I think on 2.4, spectrum analysis is a very, very important thing to be done before we go ahead and do a site survey. Understand this. A good way to deal with all these things, a very simple way, is simply move to 5 gigahertz. 2.4 has a lesser frequency band of 72 megahertz, which is, if you've not taken the first course of wireless fundamentals, I'll just tell you right now, the band 2.401 to 2.473 gigahertz is the space that we get to transmit data on the Wi-Fi. That is a 72 megahertz of width of traffic, and in this we have 11 channels, out of which 1, 6 and 11 are non-overlapping channels. So this is too short or too less a space, and we have a lot of interferers in this 2.4 gigahertz spectrum. Simple, easy way, move to 5 gigahertz. Absolutely, you're gonna be really happy. You'll be glad that I told you this. Move to 5 gigahertz and stay away from all these interference sources. Having said that, 5 gigahertz is not completely free from interference, but the frequency space that we get when compared to 72 megahertz is approximately 555 megahertz. So this is massive, and guys, if you don't know this, then I highly recommend that you take the wireless fundamentals course as well. This is all explained in detail in that particular course as well. So cool. Move to 5 gigahertz, and there are some sources of interference on 5 as well, which could be a cordless phone again, which is designed to specifically work on 5 gigahertz. There are some radars near the airports, near the military buildings, near any important areas where the radar detection can also defer transmission on that 5 gigahertz band. We have some digital satellites that can cause a problem in 5 gigahertz. We have some and basically some sensors also work on 5 gigahertz. And just like 2.4, we have nearby 802.11a and 802.11n, 802.11ac and 802.11ax transmissions or WLANs, right? So this can be a major issue when we understand, or when we try to do spectrum analysis of 5 gigahertz. However, the effect of these is very, very low, because we have around 24 non-overlapping channels compared to 3 and 2.4. So yeah, move to 5 by all means. You get better throughput, you get better space to send traffic, and that is less crowded. And of course, the sources of interference are very less, and they don't really matter much because of the wide channel that we have, or wide transmission space that we have in 5 gigahertz spectrum, right? So this was all about spectrum analysis. Of course, once you finish this, there are some devices, like you can use the device like the Ekahau Sidekick, that can help you with site surveys, that can help you with spectrum analysis. You can receive a device from Air Magnet as well, that also does spectrum analysis, but and I'm sure some other devices also. So what you do is, you basically have a laptop. I'll just give you a brief idea as to how this is done. You have a laptop, and you have a spectrum analysis antenna, which you can place somewhere here or stick it to the top of the screen, and then this is configured to get data on 2.4 gigahertz and 5 gigahertz. Okay, and then you run a software on the screen, where you when the antenna is gathering data, it is being displayed in this particular software like this. And when the spectrum analysis finishes, you create a report which will give you all the sources of interference in 2.4 and 5 both, and then you can take actions accordingly. So before you deploy a Wi-Fi network, make sure this is something which is addressed. This is something which is taken care of, because this, in a network, if deployed properly, and if it has a lot of interference around it, it can really ruin the transmissions of the Wi-Fi network. So even if you have good APs working, a source of interference can drastically hamper your network. So keep in mind this, guys.